that a reflection is just the big kid word for a flip. And so before we start, we got to have something to flip in the first place, right? Do you guys need something? Y'all need me? Okay. So we need something to flip in the first place, right? So start off by graphing a triangle, please, with those 3 vertices. So A will be at 3, 4, B will be at 4, -1, and C will be at 0, -3. Because believe me, mine's not going to be all that pretty. I can tell you that right now. I kind of suck at this. For somebody that has, it's a good thing I'm not like a full-time like actual geometry teacher, because my kids would be struggling because my shapes are not good. So just do a decent job. And somebody double check me and make sure I actually graphed those correctly, please, because I could have goofed that too. So in order to reflect something, we've got to have something to reflect it over, don't we? And so I'm going to ask you, friends, to reflect this. We're going to do this first one. We're going to reflect it. Oh, it would help if I had a pen instead of a highlighter. Hold, please. So I'm going to ask you to reflect this. Depending on the textbook that you read or the teacher that you have, whenever they say reflect it across something, or they might say reflect it over something, it just means the same thing. Sometimes you'll see them say the word reflect it about. Like they use all those weird terminology, but I typically just say reflect it across or reflect it over. We're going to reflect this shape across the Y axis. So remember that the Y-axis is that one, right? So what we're getting ready to, and this is called the line of reflection. In order to do a reflection in the first place, yes, Dia? That's an excellent question. All right, so this is called my line of reflection. It's the line that you're flipping the shape across. So the only thing you need to make sure that you do, and this is where I would switch to a different color for the image, guys, but that's just me. If you don't want to, but I think it would make it easier for you. So look, I'm going to look at coordinate A. And the fact that coordinate A is 3 units to the right of that line of reflection, that means that A prime is going to have to be 3 units to the left of that line of reflection. It's going to be a mirror image. So A prime, I'm going to get rid of this, is going to be right here. So if you're a visual person like me, it's helpful to note a few things. First of all, you should be able to draw a line, like they should still be perfectly lined up between your image and your pre-image. They should be directly across from each other, just like you're looking at yourself in a mirror. You're right in front of your own reflection. And again, it should be the same distance on either side from that line of reflection. Coordinate B, same concept. Coordinate B is what, 4 units to the right of that line of reflection? Yes, Dia? Oh my gosh, of course. Yes, this is going to be very helpful if you can see. So it's 4 units to the right, which means that your reflection needs to be 4 units to the left. So my B prime will be here. Again, see how I can draw a straight line in the original and the new version, like line up with each other, the image and the pre-image line up. And then I just had a wonderful question at table 2 about point C. And what's going to happen to point C when we flip that shape? Lucy, what's going to happen to it? It's just going to stay put. And so the great question I had was, well, do you put a C prime? Like, do you just put it in the same spot? And it really just kind of depends on how picky your teacher is, if I'm being really honest. Because personally, my opinion is that it doesn't move. So you really don't even need to relabel it. You can just leave it there. And that's the way I would count it correct. Like, if it bothers you, if you want to put it like a different color dot in there, you certainly can. But the C didn't move. So in my opinion, it doesn't really need the prime. And it's kind of correct either way. So we should have let me get that B out of there over on the other side here. So now we have triangle A, B. So whether you put the prime or not, I would count either one correct if this were some kind of mastery. So as long as you've got the shape and it is reflected across the axis, you are good to go. So you just got to make sure that you've got it lined up. So I always kind of eyeball it and double check and make sure that the image and the pre-image are across from each other. And here's another way that you can check yourself and make sure you did it right too. If you're like me and you're somebody that has a tendency to make a lot of silly mistakes, there's a pattern in the coordinates that you can use to help yourself. So coordinate A, for example, was originally 3, 4, right? Now coordinate A prime is -3, 4. So what do you notice about the coordinates? Exactly the same digits, but what's different?
The 3 is now negative.
Exactly. So your x coordinate has just flipped from being a positive to being a negative. So I always like to go back and check my coordinates and see if there's a pattern, and that helps me to double check and make sure I did it right. Ethan, I'm gonna get Riley and then I'll be right there. Yes, Dia?
That has a name, doesn't it? I forgot it.
Which thing has a name?
How it's the opposite of it. I forgot what it is, but I think.
Oh, are you thinking of the word inverse? Additive inverse?
Yeah.
Yeah. Ah, Miss V really taught you last year. That's a term a lot of people don't remember. Yes, it is an additive.
I didn't remember.
Oh, well, you kind of did. You knew there was a word. So if I were you guys, especially while you're new at this and you're more likely to make some mistakes, look at the coordinates and make sure if you don't see a pattern, then that means you made a mistake. Nora, I'm going to answer Ethan's question and I'll get you. Yes, dear. Thank you. See, that's the kind of stuff you're right. That should be -1. Thank you. That was a test. I was making sure that everybody was paying attention, and Riley's the only one that passed.
Definitely.
The rest of y'all, cross the X. And, of course, I see why this person was asking me this. Let's go ahead and erase. We'll take away all that good stuff. I'm just going to go to a blank page, actually. We're going to regraph the same triangle, though. So I'll remind you. So what was it? It was 3, 4, 4, -1, and 0, -2, right?
-3.
Oh, -3. Thank you. Look at you. All right. So we're going to graph the same triangle again. So erase whatever you need to give yourself kind of like a clean slate. So we've got A. Although I think I did the coordinates different last time, but yeah, you're right. This was C. And that was B. Y'all got to help me. I'm old. My brain is not what it used to be. All right. So same original triangle, and I had an excellent question a moment ago where somebody asked me, well, can you even reflect that across the x-axis? And I understand why this person was asking that, because it does look kind of weird, right? Because it's sitting on the x-axis. And the answer is yes, you can. It's just going to look a little weird. This is why a problem exactly like this one is why I suggested you have 2 different colors of marker so that you can tell the difference more easily between your image and your pre-image. And it still works exactly the same way. It's just that visually it looks messier. So frankly, we're probably not going to like it that much, but it's still correct. So I'm going to start with coordinate A. And the fact that coordinate A, if I'm looking at my reflection line, so this time our line of reflection is going to be our x-axis instead. And I'm going to change ink colors. The process is still the same. So A was 3 units above the x-axis, above that axis of reflection, or that line of reflection, right? So where's your best guess? Where do you think your A prime is going to go? Instead of 3 above, it's going to go, 3 below. You can just yell at me because I think some of you guys are already doing it. Yeah. So you guys look like some of you are already doing it. Yes, ma'am. Oh, shoot. See, that was another test. You passed. Good job. Good job. Good job. All right. So because it's 4 above, now it's going to be 4 below. So our A prime, if you need a different marker, guys, again, the box is up there. I know they're probably not. These are the ones that I brought from last year, so I can't guarantee what kind of shape they're in. I really need to order, like, new ones. So my A prime is going to be there. I know visually we're kind of like, oh, this looks cluttered and we don't like it. Doesn't mean it's not mathematically correct, though. And I would double check myself with the coordinates. So that original A coordinate is 3, 4. And now my coordinate is 3, -4. So you can still see the pattern. The numbers are the same. It's just that your y coordinate flipped from a positive to a negative. It flipped to its opposite inverse. Using that same pattern, we're going to do that with coordinate B next. So B is one coordinate below the line. So where is my B prime going to be once I flip it over that axis? One above, exactly. We don't like it because it looks messy, because it's sitting on top of each other, but it is correct. I would double check myself by checking those coordinates. So my pre-image was 4, -1. My image is 4, +1. So the pattern still holds. I probably did it right. And last but not least, if coordinate C was 3 below, now it's going to be 3 above. We don't really like the looks of it because it's, well, first of all, I can't draw for crap. I recognize that. It would be nice if they were straight lines. It doesn't look all that great. Our brains don't really like it when it's like overlapping like that, but it is mathematically correct. And I'm going to use the coordinate to double check. It was 0, -3. Now it's 0, +3. The two problems that we just did are what is expected out of 8th grade math. So 8th grade math, you're only expected to be able to reflect something technically over the x-axis or over the y-axis. I am going to show one other tiny example. You may see, and this is to your point, Ren, you might see like a shape. You don't need to write this one because it's not on the grid, but we may have something like, let's say I've got this triangle, A, B, C, and it might say reflect it across. Do we know what that symbol means that I just wrote down? The AC with the line over the top of it. Do we know what that means? Okay, what does that mean?
It means you're going to reflect it using instead of using the y or x-axis as the reflect line, the AC line is going to be the reflect.
Correct. Sometimes you will see that. And then in this case, if I did reflect it across AC, is AC going to move at all? No. So really the only thing you would do if you were sketching something like this out is really all you need to worry about. Okay, well, B was up there. So now B is going to be, like down here. But then the rest of it stays the same. So yes, those do exist, and I love that you asked about that. We're not going to do too many of those because more in 8th grade and 9th grade math, we're more about doing stuff on the coordinate plane. But you will see it like occasionally, not as often. So again, reflecting over the x-axis and y-axis is pretty much what you need to know for 8th grade math. So this next example that we're going to do is what makes this an Algebra 1 example. Yay for algebra. All right. So instead of reflecting it across the x-axis or the y-axis, we are going to reflect it across y equals x. So that is a line. That is the equation of a line. We are going to talk so much more about equations of lines. You're going to be honestly sick of it, probably by the time Christmas rolls around or the holiday break rolls around. But so don't focus too much on this. The basic idea of this line is that your x coordinate and your y coordinate are the same. That's why it says like x equals y. So for example, 0, 0 is going to be a coordinate because your x coordinate and your y coordinate are the same number. So by that logic, where would I put another coordinate to represent that line? Ethan, what you got for me?
6, 6.
Exactly. So 6, 6 would fall on that line because your x coordinate and your y coordinate have to be the same. Give me one more. Give me one more.
Negative 6.
Ooh, negative 6, 6. I love it. So these three coordinates fall, so it just basically makes a diagonal line that just cuts the whole coordinate grid in half because your x coordinate and your y coordinate have to be the same. So do your best to kind of eyeball it. I know you don't have a line tool like I do, so yours probably isn't going to be perfect, and even for a straight line tool, mine's still not that perfect. But I just want you to have the general idea of what that looks like. So the equation y equals x just makes a diagonal line that cuts the entire x-axis in half. So I'm going to graph that 0, negative 3 that was point C or on the x-axis. And it's really hard to eyeball exactly where coordinates go on the other side of this axis. Because when you've got an x-axis or a y-axis, you can just count boxes straight across or up and down. But guys, are these just straight across boxes? No, they're like diagonal, right? So you can't really count exactly the same way that you can if you're just counting across. But here's the general idea. So here's what it should look like. If I pick that coordinate up and I flip it across that line, so C was right here, and now C prime is going to be right here. It's harder to tell because you're having to eyeball it diagonally. And this one was a little bit easier because it's like pretty close, because they're not too far away. But it's really hard to eyeball it once you've got, if you've got one all the way over here and you're trying to reflect it all the way over there, it's really hard to visualize exactly where it goes. So this is one of those times that using the coordinates is easier. Let me show you what I mean. So the original coordinate for C was 0, negative 3, right? What's the new coordinate for C prime? Negative 3, 0. So what happened to those coordinates? Did a sign change at all? Did a positive change to a negative or a negative change to a positive? They just flipped. So that is the rule for how you flip something across that diagonal line. All it is that the coordinates flip. So instead of 0, negative 3, now it's just going to be negative 3, 0. So you can use that to help you in order to be able to graph the other. So what was my other coordinate was, let's see, A was 3, 4, right? Is that what it was?
Yes.
Thanks. So coordinate A, for example, the original was 3, 4. So what is the A prime going to be after you flip it across that axis? If they just switch places, what's A prime going to be? Instead of 3, 4, it's going to be 4, 3. Exactly. And looking at it, you can tell they're about the same distance across. It's just hard to tell without using the coordinates. And then finally, what was my coordinate? What was B? Somebody have that written down. Do y'all remember for me?
It was 4, negative 1.
Thank you. 4, -1, the one I screwed up earlier. So 4, -1 was my b. So what does that mean that my b prime is going to be? -1, 4. Exactly, because it's the same numbers. They just flip. Ooh, that was bad. So again, visually, we don't like it. And I really suck at drawing, so it looks terrible. We don't like it because they kind of overlapped each other, but it is mathematically correct. So whenever you're flipping across that diagonal line, x equals y, all you need to do is just flip the coordinates. And in my experience, it's way easier to just use the pattern of the coordinates than it is to actually try to graph it by eyeballing it. So my new a prime is just going to be 4, 3. My b prime is -1, 4. And my c prime is -3, 0. So when it reflects across the x, when it reflects across that diagonal line, all you do is just switch the x and the y coordinates. And just because it looks messy and crappy and it's like overlapping each other doesn't mean you did it wrong. A lot of the time, especially when you start doing more advanced ones, that's what it looks like. Okay? So that you're wondering. But I think I've thrown enough at you as far as playing around with the, patterns and all that. That question is coming. But yes, so yes, stay tuned. Yes, Riley.
So it's like on like previous problems they've asked you if this is a reflection or a rotation. If you do it like this, how do you tell if it's a reflection or a rotation?
Oh, that's a great question. So let's look at, how do I know that's a reflection? If it were a rotation, it would still be like, it wouldn't look like a mirror image. See how they're literally like C and C are backwards from each other? B and B are backwards from each other, but and then A and A are right across from each other, but they're backwards. A rotation won't look like that. I'll show you some, and we're actually going to do rotations tomorrow using something called patty paper, like a hands-on version that I think is going to help. I think it'll be easier to answer your question, although it's a great one. I think it'll be easier to show you tomorrow because we're going to actually do kind of a hands-on version of that one. But that's a great question. This is definitely not a rotation because they're like backwards, they're like mirror images of each other. And a rotation wouldn't look like that. All right. Oh, yes, dear.
Plus none of the points are like touching.
Ooh, great call. It didn't actually. Ooh, tomorrow though, I'm going to mess with your head. I'm going to show you some where they're not touching. I know, right? Oh. But for now, you're right. We haven't done any like that. All right. So guys, what if the line were going down like that instead?
Yeah.
Stay tuned because it's a little different. We are going to do some of those too, but not today.
Okay.
I definitely can. The equation of this line is y equals -x instead of y equals +x, and there is a pattern to it. You can learn how to do it. It's really not that hard, but